I'll introduce our work in 3 parts. Let's begin with a motivating example. In online recruitment, as the resumes arrive sequentially, the HRs use machine learning tools to shortlist the candidates and want to select the suitable candidates into the interview process. However, there are several problems. First, how to reduce the cost of the subsequent interview process for unsuitable candidates. This motivates us to control the false selection rate to avoid containing too many unsuitable candidates. And second, how to contain suitable candidates with different backgrounds to enrich the diversity. This motivates us to control the similarity among candidates at a desired level. And we formulate the problem as a general constraint online sample selection. A sequence of ID unlabeled data arrives in a stream with their response unobserved all the time, and at every time t, we should make decisions delta t on whether to select it or not until stopping. And we want to design a real-time selection procedure that can control various constraints at user-specified stopping time. A natural idea is to use the labeled history data to estimate mu hat and obtain the predicted value. Use the predicted value to approximate the true value. However, there are several questions. First, how should we quantify the prediction uncertainty to make the decisions reliable? And second, how to make the selected subset more representative? And finally, how to make selections in the online setting. To solve these problems, we propose a method, individual and interactive constraint online selection, wblxm5zdkE. First, to quantify the uncertainty of response predictions using predictive inference, and we focus on 2 general types of constraints. The first is individual constraint, and the second is interactive constraint. The individual constraint can capture each selected sample's cost associated with seat and X, and the interactive constraint can capture the interactive influence among correctly selected samples. This is the formulation of these 2 constraints, and one example of individual constraint is for selection rate, and the interactive constraint can capture the similarity or diversity of the correctly selected samples. And these are 2 closely related topics of our work. The first is online multiple testing, and the second is the predictive inference. We review the literature in our paper. And the core idea is to leverage the predictive inference and use the 2-group model. With the 2-group model, we have the expectation of theta t conditional on xt equals to 1 minus lt, where lt is the local false discovery rate. So theta t is equivalent to 1 minus lt in the sense of taking expectation. Therefore, if lt is known, it's easy to obtain our decision rules. However, in practice, since LT is unknown, we adopt a data splitting strategy to estimate LT and propose a data-driven procedure. So our procedure contains 2 steps. The first is offline estimation, and the second is online decision. In the first step, we use the history data to estimate mu hat and estimate L, then use them to the decision rules and make our online decision. And we, regarding to the theoretical results, we provided the bounds for individual constraint and interactive constraint under 2 mild assumptions. We compare our method with 4 online multiple testing benchmarks, and according to the results, only our method can control these 2 types of constraints simultaneously at each time. And you can find more details to our paper. Thank you.